Hi, my name is Milan, and in today's video we're going to talk about Amazon S3, which stands for Simple Storage Service. S3 is a general-purpose object storage solution in the AWS cloud and is designed to be highly scalable, highly available, durable, and it also integrates with many existing AWS services. In this video, I'll show you the best practices of working with S3 from a .NET application. You'll see how to use the S3 SDK, how to work with presigned URLs, and also we're going to cover multi-part upload for very large files. I also want to say a huge thank you to AWS for sponsoring this video and helping me bring AWS closer to the .NET community. So let's jump into the video. We're going to start from the AWS console and let's navigate to the S3 service. If you have recently visited this service, it's going to show up here, but you can just type in S3 in the search bar and then navigate to the Simple Storage Service. And here you will see the available buckets that you have created inside of S3, and this is one of the core concepts of the S3 service. You can think of the bucket as an individual file system that contains your objects for your application. You can upload any number of objects inside and they will be grouped inside of the bucket. Within the bucket itself, you can also group your objects into folders, although these are logical constructs, and I'm going to show you how this works later, but let's first create our bucket that we're going to use in our demo. So I will click Create Bucket, and we first need to assign a unique name for the bucket. So let's say I call it MJ Tech Test, and if this bucket name is not taken, then I will be able to use it. Now let's see what are some other things that we can configure on an S3 bucket. First, you can decide if your bucket can be owned by other AWS accounts. I'm going to check Disabled for this option. And this is one of the most important things when working with S3 is if you want to allow public access to your bucket. By default, this will be turned off, and this is excellent from a security perspective because there were many data leaks in the past that were linked to incorrectly configured S3 buckets. So the safest approach is to leave this checked. We want to block all public access to our bucket, and then I'll show you some different ways how you can expose the individual objects that you upload to the bucket. The next setting that we can configure is if we want to enable bucket versioning. Using versioning allows you to upload the same object with the same key multiple times, and S3 will take care of properly versioning this object, allowing you to work with different historical versions of the same object. Something like this can be very useful when working with documents. For our demonstration, I'm going to leave this as disabled and I will not be using bucket versioning. For the other things inside of this configuration, I'm going to leave all of the default values and then I will click Create Bucket. And assuming that our bucket name is unique, and you can see that it was, our bucket will be successfully created. So now I can go into my bucket and start uploading some objects. From here, you can manually upload some object into your bucket by clicking the Upload button. And for example, I can choose Add File, and let's upload some image that I already have from a thumbnail of one of my previous videos. Something I want to highlight is that you can choose the storage class of your object, and this is going to determine a few options to how this object is stored. It's going to impact the latency, how fast you can upload and retrieve this object, and it's also going to impact your cost. So the default option is the standard storage class, but you also have a few other options that are meant for files that aren't accessed so frequently. I'm going to leave the standard tier, and then let's upload our file. And after a few moments, you can see that our file is uploaded. And if I go back to my bucket, you will see that the object that we just created is right here. What I can do now is go into the individual object, and I can see some of the settings for this object. If I try to access the object URL, I will be greeted with an access denied response because I disabled public access to the objects inside of my bucket. So what you can do as an alternative is share with a presigned URL, and this is how you can securely expose the objects inside of your buckets. So let's say I want a presigned URL that's going to expire in 1 minute. I can create it and it will be copied to the clipboard. If I go into the presigned URL, this is what I will get back. This is the image that I uploaded to my S3 bucket, and this is a thumbnail for one of my previous videos where I discussed using SQS and SNS with mass transit, and if you didn't watch that video, I highly suggested you check it out. So let's close this and let's go back to our object, and let's say I decide that I no longer need it. I can go ahead and delete it from my bucket, and I will have to type in that I want to permanently delete it. This is a precaution so that you don't accidentally delete stuff, but in our case this will be fine. A few more things that you should know about your S3 bucket. If you go into the permissions tab, you can see the public access settings. I mentioned that this was important and we're going to block all public access to this bucket. Now you can also define your bucket policy, which is going to be an IAM policy that's going to define who has access to the objects inside of this bucket. And you can also configure your core settings, which is something that we will need later when we start working with Presigned URLs and multi-part uploads. But first, let's see how we can use the S3 SDK inside of a .NET application to start using our bucket. We're going to start from a mostly blank application, and the first thing I want to do is to introduce a class that's going to represent my S3 settings. I will make it internal and sealed, and I just want to have two properties on the settings class. One is going to be the region name, and I'm going to give it some default value, and another one is going to be my bucket name that I will be using to upload my objects into. Of course, you could work with multiple buckets inside of the same application, but for our simple case, this is going to be sufficient. Let me also add some configuration values in my app settings development JSON file. I'm going to add the region value and my bucket name, and I will actually have to update my S3 settings to rename this property into region to match the value that I have in application settings development JSON. And then I'm going to add a piece of code that's going to configure my S3 settings as an options instance, and I will be able to use it from my API endpoints. The next thing we will need is the S3 SDK. So let's go ahead and install that NuGet package. If you search for S3, you will find the AWS SDK S3 NuGet package, and I'm going to install the latest version. This is going to expose the S3 client that we can use to interact with the S3 service. And I'm going to add the S3 client as a singleton. We're going to say I Amazon S3, which is the interface, and then let's provide the implementation through a delegate that lets me access the service provider. I'm going to do this to be able to resolve my S3 settings, and I'm going to say service provider get required service I options of the S3 settings class, and then I can use the value that I get back. Then I'm going to create an S3 configuration, and here I just want to set the region endpoint by resolving this value from the region endpoint static method, which is called getBySystemName, and I can provide the region name from my S3 settings instance. And finally, I'm just going to return a new Amazon S3 client, and I will pass in my S3 configuration. And from here, we are ready to start working with the S3 service. So let's expose a post endpoint that's going to allow me to upload some file into the S3 bucket. So I'm going to expose this with an images route, and then let me define a few things that I will need in my request delegate. So I want to bind a value from the request form, and this is going to be an iForm file. This is something that you couldn't do with minimal APIs up until recently, but now we can use the iForm file, so why not use it to make this simpler? Then I'm going to inject the S3 client, and I will also need an instance of my S3 settings, so let's go ahead and inject that. And then let's see what we need to implement this endpoint. I'm going to close down the other files that I have. And let's say if we don't have any files, then let's return a bad request. Otherwise, we're going to open a stream for the file that we have by saying open read stream. Then you're going to need to provide a unique value. This will represent a key or a unique identifier for the object that I want to upload. And this could be anything you want. For example, you can use the file name. I will use a GUID value to make my object names completely random. And then what I need to do is to create a put request to upload this file into S3. So I will need to create a new put object request instance, and then I need to assign some properties on this object. I will need to set the bucket name, and this will come from my S3 settings. So this is how I can provide the bucket name through configuration. Then for the object key, I'm going to provide a string that's going to be the key value that I generated earlier, but I'm going to add a logical component that's going to be images / and this will be translated into a folder when I upload this file into S3. Then I will need my input stream. We already have that from earlier. Let's also assign the content type. We can grab this from the form file that we have, and then you can optionally provide some metadata that you want to associate with this object. Let's say I want to keep a record of the original file name of this file, I can do that by providing a metadata value, and I can access the file name using my form file. So now the original file name will be available as metadata, and the file name in S3 is going to be the key value. S3 has a standard prefix for user-generated metadata. It's XAMZ meta, but you don't have to provide this manually. It's going to be appended if you leave it out. So that's exactly what I'm going to do. So now we have our put object request, and we can go ahead and use the S3 client to call the put object async method and send the put request. And finally, when this completes, I can go ahead and say return results.ok, and let's, for example, just return the key value. Another thing that I will have to do is to disable anti-forgery in order to be able to use form files without having to provide an anti-forgery token. So this is just a small hack that I'm introducing to make this work with minimal APIs. So let's go ahead and start the application and test out this endpoint quickly. From the Swagger UI, I'm going to execute my endpoint, and let's choose the same file that I already used in the previous example, and when I hit execute, I will land on the breakpoint in my minimal API. And here you can see that we do indeed have a file. The length is non-zero, and I'm going to go ahead and create a key, create a put request, send this to my S3 service using my S3 client, and all of these values are provided through dependency injection. And when we get to this line of code, our upload is complete. I'm going to hit continue. We will get the key for this object as a response. And now let's go into S3 and confirm that our upload is actually working. So I'm in my S3 bucket, and if I hit refresh, you will see that the images folder shows up. And if I navigate inside, I can see the one object that I have here. You can see that the identifier matches what we got back in the Swagger response, and I can go into this object, access the individual value if I need it. Next, I want to quickly show you how we can download this object using the S3 SDK and also delete it when we no longer have a use for it. Okay, now let's go ahead and add another endpoint. There's going to be a get endpoint. The route is going to be images and then key, because I want to provide the key value through the route. And then let's define the request delegate. I'm going to define the key, and then I will reuse the services that I have in my previous request. And what we need this time is a get request. So we instantiate a get object request, and we will need to provide a bucket name. We can do that from the S3 settings, access the value, and provide the bucket name. And then for the key, it's going to be images/key. I won't be doing any validation to check if this is a GUID or something. Let's just assume that we provide the correct key value. And then we can get the object by saying await S3 client, and I can call get object async and provide the get request. From here, we can just return this object directly. I can say results file, and then from the response, I can provide the response stream. I also have access to the content type from the headers, and if you recall, we stored the original file name in the metadata, which will also be included in the response. So this is how I can implement a simple get endpoint. One thing that we should keep in mind is error handling, and S3 is going to throw an exception if the object that you're trying to retrieve doesn't exist. So we can introduce a try-catch statement here to handle that case. I'm going to leave that out because I'm going to show you a better way how you can return a file from S3. But for now, let's quickly start the application and confirm that this is working. And I'm going to do that by sending a GET request from Postman, because it's going to automatically download the file, and you can see that I get the file back, which is a very big document, so I'm not able to see the entire thing, but we can at least confirm that this is working as expected. Let's go ahead and reuse this same endpoint for the delete functionality, and you will see that this is mostly the same. I need to send a delete object request instead of a get object request, and I also need to call the delete object async method to be able to send this request. Let's return results.ok if this completes, and I won't be managing the response. By default, S3 will return a no content response when you successfully delete the file, but it's also going to return the same response if the file doesn't exist. So let's go ahead and quickly test out the 3 endpoints that we have so far. I'm going to start by uploading a file. Let me choose the same file as we already have, and I'm going to get back some identifier representing my object key. Then I'm able to retrieve this file from S3 using my get endpoint, and in the Swagger UI, this is what the response looks like. Now, if I try to delete this file, I'm going to get a 200 OK response because this managed to delete the file. And if I try to retrieve it from my S3 bucket, I'm getting an exception. This is going to be an Amazon S3 exception. And this is the exception that you should take care of in your code. So this confirms that our delete endpoint is working as well. And now let's move into some more advanced topics. The one problem that we have with the current setup is that we are fetching the file from S3 in the get endpoint just to return it to our client. So in essence, the file is traveling twice, once from S3 to our API, and then from our API to the client. And this is neither efficient nor scalable, and is going to quickly make our API the bottleneck in the process. And the same applies when we are uploading the files into S3. So luckily, there is a better solution from the approach that we are using so far. And this also solves the problem of not making the object publicly accessible. So S3 has a concept of presigned URLs, and these are URLs that you can safely construct on the backend and return to your client. And then your client can use them to interact with S3 directly. So let's create a new endpoint called images, and then let's specify the key in the route, and I'm going to call it presigned. Then I'm going to define my request delegate, and let's also do some error handling this time. Let's say I want to catch an S3 exception, and if we do run into this exception, let's return a bad request. So we can say return results, bad request, and let's just print out the exception into the console. And then, as with any other interaction with S3, we need to create some sort of request object. And this is going to be a get presigned URL request. So let's see what are some values that I need to assign here. I need to say what is the bucket name that I want to fetch the presigned URL for. I also need to provide my object key, which is going to be images/key. Then I need to say what is going to be the verb for this presigned URL. I'm going to use HTTP get. If you are using versioning, you can also provide the specific version ID that you want to fetch. And then the most important thing that I want to set is when this presigned URL will expire. I'm going to say datetime UTC now. And let's, for example, add 15 minutes, and this will make our presigned URL valid for 15 minutes from the time when it's generated. And then you can just generate your presigned URL. You can say S3 client, get presigned URL, pass in your request, and you will get back a presigned URL instance. Now I'm going to return an object as the response here, and it's going to contain the key and the presigned URL value that are going to be formatted as a JSON object. Let me also make the capital S so that I'm not getting the warning anymore. So this is how I can create a presigned URL. Now let's start this and let me show you how this works. I'm going to grab an object key for an object that I already created. And when I send this request, I'm going to get a response back with the object key and then the presigned URL value. And this is the same presigned URL that I showed you at the start of the video, only now we are exposing it through our API. So our clients can integrate with our API by requesting a presigned URL. We're going to return a value like this, and then I can navigate to this presigned URL, and I will get back the object that I uploaded to S3. So now I can completely avoid my backend, get a presigned URL, and go directly to S3. And this also works for uploading files into S3. I can get a presigned URL for uploading a file and upload a file directly to S3 from my client without having to buffer the file into my API, making the API a bottleneck. So let me show you how you can implement this and how you can integrate it with a client application. I'm going to introduce another endpoint, and I'm going to just paste the code in because it's very similar to what we already discussed and is going to make our implementation slightly faster. So I'm creating a post endpoint with the route of images presigned, where I'm specifying a file name and the content type of a file that I want to obtain a presigned URL for. Then I'm creating an object key, and I'm creating a get presigned URL request just as in the previous example. However, now I'm specifying HTTP put as the verb for this presigned URL. It also has an expiration. An addition is specifying the content type, which I'm providing through a query parameter, and I'm also specifying the file name in the additional metadata for this object. And then I'm creating my presigned URL and returning this as the response. And now all I need is a client application that's going to integrate with this endpoint. And this is what the client application looks like. I'm going to use this to demonstrate how to upload a file using a presigned URL, how to get a presigned URL from the client side with the endpoints that we just created. And I'm also going to show you how to do a multi-part upload directly into S3 for very large files. But let's go into the code for this client application for just a brief moment. This is a plain HTML and JavaScript application. There are no frameworks and it's just served through a local HTTP server. I want to show you what happens when I click the upload button, and hopefully this code won't be too complicated to understand. We have a call here that's going to send a post request to our API to obtain the object key and the URL, which is actually our pre-signed URL for uploading to S3. Then it's going to log something into the console and it's going to try to upload the file that I selected in the form directly to S3 using my pre-signed URL. So if I go into this function here, it's hitting my backend API and it's targeting the images pre-signed endpoint. This is the part that we have control over. And then here is the upload file to S3, where we are using the pre-signed URL, and I have some JavaScript code that's going to attempt to upload the file and also update some progress loader. So let's go ahead and try this out. I can go ahead and select a file from my client, and with the file selected, I can click upload file. And this is first going to land in the breakpoint in my API to generate the pre-signed URL. And you can see that all of this succeeds, but when I click continue, I'm going to run into a problem. And the reason for this is cross-origin resource sharing. So we will have to go into our S3 bucket, navigate to the permissions tab, and update our cross-origin resource sharing policy. I'm going to click edit, and I'm going to paste in a policy that I already prepared beforehand. I'm allowing all headers, I'm allowing the get, put, post, and delete methods. For the allowed origins, I'm specifying localhost 5000, which is where my client application is exposed. And then for the exposed headers, I'm specifying a few headers that I will need later for the multi-part upload. You will see where we are using these header values when implementing the multi-part upload. So I'm going to save these changes, and then let's attempt to upload our file the same as before. I'm going to click upload file, and you can see that the file is uploaded successfully. I can go ahead and use the object key that I get back and paste it into this form to get a pre-signed URL. And if I click this value, you will see that our upload is working using pre-signed URLs, and we're also exposing the file through a pre-signed URL. So now we are able to easily upload a file directly into an S3 bucket using a pre-signed URL. Let me show you what happens when I use some very large file. I'm going to choose my SQS video, which is around 3.7 gigabytes. So if I go ahead and try to upload this, you will see that my upload is definitely working. I'm able to get a pre-signed URL from my API and then start uploading the file directly to S3. However, this isn't too efficient because I'm sending a very large file directly into S3. I believe the S3 recommendation is that whenever you have a file that is larger than 100 megabytes, you should be using the multi-part upload. So now I'm going to show you how to implement a multi-part upload, and we will need to introduce a few API endpoints to support this functionality, and then also integrate with these API endpoints from the client application. I'm going to refresh the page, and this will hopefully stop the upload, and I also confirmed in S3 that the file is not there. So before we discuss multi-part upload, let's spend a moment to talk about the S3 pricing. Amazon S3 has a few storage tiers, and this is what actually determines your pricing. So the default tier is S3 standard. It's a general purpose tier for any kind of data, and it's recommended for frequently accessed data. So you can see that the price is pretty cheap. For the first 50 terabytes, you're paying like 0.023 cents per gigabyte, which really isn't all that much. There is also the S3 intelligent tier, but if you keep scrolling down, you can find the infrequent access tier, which is for objects that aren't accessed that frequently, but still you need millisecond access when you want to get them. And you can see that it's about half the price compared to the standard tier. If you keep going down, there is the glacier tier, which is meant for objects that aren't accessed all that frequently, and you can think of it as some sort of cold storage. There is also the Glacier Deep Archive, which is one of the cheapest options on S3, and when you need to access the file, it can be restored within 12 hours. So these are just some things to keep in mind when it comes to how you're storing your files in S3 and which tiers you're using. This will impact both your S3 costs, and it's also going to impact how fast you can get the data back from S3. So now let's go back to our API and see how we can implement support for multi-part upload. We're going to need 3 additional endpoints to support multi-part upload, and I'm going to add all of them and then walk you through what we have inside. I also added 2 classes behind the scenes, and I'll show you what they are and why we need them. So how multi-part upload functions with S3 is that we first send a request to start a multipart upload request. This is going to give us back a unique upload ID that we can use when uploading the individual parts for the large file. So in this endpoint, where we are starting the multipart upload, I'm specifying the file name and the content type. I'm generating a unique key for my object, and then I'm creating an initiate multipart upload request. All of this is pretty standard. We just specify the bucket name, the key, the content type, any metadata that we need, and we send the request using the S3 client. And as I said, we are returning the upload identifier as the response from this endpoint. The next endpoint that we need is to generate a pre-signed URL for an individual part. Here, we're going to specify the object key, the upload identifier, and the specific part that we are trying to upload. And this is almost identical as the request to generate a pre-signed URL, except we're also specifying the upload identifier in the respective property. So we get the pre-signed URL, we return it from this endpoint, and then from the client side, we can upload a specific part with this part number. And finally, let's say we uploaded all of our parts. For example, we split the file into 10 parts. We're going to call the third endpoint that we need here, which is the complete multipart upload. We just specify an object key and an object called complete multipart upload. Now, if I go into this object, it has a key, which is kind of redundant, but nevertheless, it also has the upload ID and the parts and the list of the parts that we uploaded. Now, an individual part is going to contain the part number and the unique e-tag value that is generated for each part when we upload it successfully to S3. So back in the endpoint, we have to construct a complete multipart upload request, specify the bucket name, the object key, the upload ID that we already have, and we also have to specify a list of part e-tags that contain the part number and the e-tag value. And finally, we can send this request to S3, and what's going to happen is S3 will take all of the individual parts and patch them together to form the final object. When this completes, we're going to get back a location that's going to represent where we can find this object. Let me go into the client code and show you what's happening there. The multipart upload logic is implemented in the file called upload multipart.js, and I'm going to walk you through the important steps. So when we are starting the upload, obviously we have to select a file, and then I'm splitting the file into 100 megabyte chunks. So this is going to be our part size that we will be uploading using the pre-signed URLs. And then we're going to go into the upload parts method. And remember that we have started the multipart upload in this step, so we already have the upload ID. And inside of this method, we're going to fetch the pre-signed URL for each of the parts, attempt to upload this part directly to S3, and we're going to store the e-tag that we get back from the upload part response. And this is how we will be able to tell S3 that we have uploaded all of the parts, because S3 knows based on the upload ID what are all of the individual parts. So when we go through all of this, we can call the complete multipart upload method, and this is just going to call our respective API endpoint and pass in the upload ID and the respective parts. So this is how our client-side logic works. Now let me show you how this actually looks like in action. I'm going to choose a file for the multipart upload. Let's select our large file, and we're going to start the multipart upload process. And this is going to open up a sidebar where you can see the upload progress for the individual parts. What's also cool here is that I implemented pausing functionality. So because we're implementing the individual parts, you can go ahead and click pause, and the multipart upload is going to temporarily stop. You can hit resume, and then it can continue uploading the remaining files. So this is going to take a moment to upload all of the files, and we're going to get back to this when it's near the end, but let's jump into the client application where I want to highlight something. If you ever watch my channel, you know that I rarely do any client-side work. I'm familiar with quite a few client-side frameworks like Angular and React, and I built my website using Next.js, but I don't generally write client-side code. Now, this time I made an exception, and I actually used AI to write this entire application, and I was blown away by how this works. I used an IDE called Cursor, and it looks almost identical to using VS Code. And what you can do is tell it to generate some specific segments in your HTML files, and then generate the JavaScript code that's going to add the functionality. And I managed to write the code for this entire website in under an hour. So there's the upload script that takes care of the upload using a pre-signed URL. There's this segment here that's going to fetch the pre-signed URL from our API, and there's also the multipart upload that takes care of splitting a large file into chunks and then uploading them one by one to S3. And all of this was generated using AI, using the Cursor IDE, and this is something that I'm going to feature in one of my future videos because you have to know about this. This is absolutely amazing. And as I go back to the UI, you can see that our upload has completed. I'm going to click OK, and we get back a key for this object. Now I'm going to try to get the pre-signed URL. This is the value, and if I click the pre-signed URL, my name is Milan, sorry for that, we will get back the file that I uploaded directly to S3. So this is one of my previous videos where I talked about using S3 with Amazon SQS and SNS. If you didn't have a chance to watch that video, I recommend that you do. And with this, we're going to wrap up our discussion about working with S3. I showed you how to use the SDK, how to do the simple CRUD stuff, and also how to do the interesting stuff with pre-signed URLs and multi-part uploads, and all of this source code is available completely for free from the pinned link that's going to be under this video. So I recommend that you grab it and you check it out, and hopefully you start working with S3 like a pro. Now, if you enjoyed this video, I would really appreciate it if you click the like button. If you want to improve your AWS skills further, I recommend that you watch this video next. Check out my clean architecture and modular monolith courses to improve your software architecture skills. And until next time, stay awesome.